Hello friends, welcome to the Laptex. My name is Nasir and today we have a HP motherboard I have received in the dead condition, and the model number is part number is LA-K201P, and it has 11 generation processor here, and I have received it from some repair shop, and he has expected BIOS is done, SIO is either changed, or you can say that he has tried to resold it. I don't know what does happen after resold it. uh, just two things I have seen in this motherboard, and it is not triggering. So I have not received a DC jack along with, so I am using my own DC jack. Okay, Laptex DC jack. So let me choose the ID of HP. So I am not checking shorting. mm, I just want to check that I am going to turn on my power supply. You just pay attention on the power supply. So the light comes on the DC jack. It indicates at least two things: that LDO is proper, your 3 volt LDO is okay, and also you can say that your IO is programmed. If it is blank, then you have no LED light on the HP motherboard, in any HP motherboard where IO is programmed. So first thing, we need to make it sure that how many states it is covering or it is turning on. However, it is written dead. My employee has written dead after having word with the client. He wrote here that it is a dead condition. So I expect that a few voltages would be there. So let me set my multimeter as well on the voltage. Now pay attention. I am triggering. So 3 volt S5 is available. Now 5 volt is also available, and after triggering you may notice here that 0.22 milliampere it takes and then goes down. So see here again, I am powering, I am switching on. Let's switch on. It goes to, so it is not called the dead situation. You can say, you can see here that on off switch light. As I press on, the light comes, and after a few seconds it goes out. Okay, once again turn on. Backside there is the on off switch, and as soon as I trigger, and it comes and goes off. This is the scenario here. If you ask me that after 3.3 and 5 volt logic, so I think 2.5 volt VPP voltage is required. So let's check. Do we have VPP voltage? No, at all, not at all. And VDDQ, let's check. Not at all. If there is a no VPP voltage on the DDR4 architecture, we cannot expect to have VDDQ voltage on any generation, any model. So BIOS, I am let me make sure. Yes, there is a voltage on that it makes sense. Sometime I have seen that there is a no VCC voltage, despite the guys who start, you know, reprogramming the BIOS. And what is the logic behind that? It goes beyond my concept. So how should we diagnose these types of problem? If laptop is triggering but uh, not up to the mark, you can see here that on off switch is given here. As soon as I will switch, you will see that something happens, but there is a no proper on. Okay, this is not proper on. So uh, how do you check this types of problem. The why this voltage this IO is done, I really don't know. If you tell me if if I tell you that after this we need to check RTC area, so of course we need to check at least 32 kilohertz. We need to make sure that it must be available. So let me power off. So there is no nearby reference, so I'm taking it from here, and let me set it on the extend. Okay, and now let me switch it to DSO. So let's come and check that do we have now uh, do we have 32 kilohertz. So what type of scenario is that? Yes, it is not touch. Yes, this is what I was expecting. Now 32 kilohertz is there, and this is the sawtooth form. This is the pure sine wave. I think reference is not good. This is the sine wave. As you can see here, I'm checking. Let me set it on the pip mode. Now I'm checking 32 kilohertz. So this is fine waveform I'm getting on the RTC 32.768 kilohertz. So what else we need to check now? One more thing, that BIOS has the data or not. So let me set it again. Once again I will put the reference at the same place. Now I am going to check the data. Chip select. Reference is not good here. There is a no nearby ground I am getting. That is why I'm checking it here. So put off, put on, and I have to turn on my board. Goes up, and it is not noticeable because the voltage is not set properly. 1 volt per division I have set, so that I can eye on 3.3 volt. Chip select. Damn it. Come and get the ground. Not at all. On the RAM slot. This might be good. Just power off. Still I'm getting the same. After powering off, I'm not getting proper ground. So where can I? It's very far. I really don't like that this type of board where there is no ground. And what about if I take it from the battery connector area? Okay, so from here I am getting the reference. Okay, let me hold it. But how can I make it on? This is the problem. No, the same. second, let me set it first. 5 millisecond. Yes, so it takes time. No, right, no. This types of problem I think you will be getting at the time of repairing. Yes, now I have just moving. Oh, my reference is broken. This is the area. First of all, we have to diagnose this. Okay, let's see you guys in 5 minutes. So I have soldered on it. Okay, now put it anywhere, it will show you the data. I am looking for data. Now it is, there is no voltage. Now I will turn on, it will show me the BIOS condition. There is no data at all. This is only high volt which is available, as it is as like on the pin number 8. It has 8 volt, and on the pin number 1 it has around 2 volt and 2.5 volt without any data. Okay, pin number 2 the same. Let me turn it off. It will automatically turn off. Remove the plug again. Go 0. Pin number 2 data out. So let me check data in first. So pin number 5 I'm checking. So it means that BIOS is not working, and when the BIOS would be able to communicate with PCH, or PCH will make BIOS communicable when it has some proper voltage like RTC, DSW. RTC will work, DSW will work, and in 10 generation and above more, like 11 generation, 12 generation, in these generations you will find a new voltage named that VCC IN auxiliary. So this voltage is required in S5 state. The generation of VCC IN voltage is 3.3 and 5 volt, and S5 power good is required. Apart from that is enable voltage. The VID1 and VID0 both need to be high, because that is the booting voltage 1.8 volt required as per the PCH datasheet. It is started from the 10 generation, and further you will keep on getting this types of logics in the newer models. So here this is the regulator. Let me switch. So here in this motherboard you have MLIC PUG1, and this regulator you can call this generates VCC IN voltage in your motherboard. Okay, so let me check it with the multimeter only. That is enough. So here after triggering, because 3.3 and 5 volt is suspended, that is why I have to hold the power button on off switch from one hand, and I will check the enable. Enable is on pin number pin number, I think not this one, this is enable, I think 90 number. Okay, so we will check it on the schematic VCCIN. So we are going to check enable. After triggering, no voltage at all, so we cannot expect to have VCCIN voltage in this motherboard, and somebody has worked on this area. This is the S5 to S0 area. So let's forget about the S0 state. Now your S5 state is not clear, I think so. Now make it sure that PUG1 we have to target in the schematic, and then accordingly we will work. So here we are bringing you on the schematic and board view. So here is the diagram, and let me copy PUG1. So VCCIN auxiliary voltage generation requires S5 power good usually. Now here it is taking enable as 1.8 volt power good. So apart from that, if this only comes, it cannot generate your 1.8 volt on this area. It requires with 0 and with 1. If this is 3 volt and this is 3 volt, then only you can get 1.8 volt on the VCCIN, which is required voltage for 10th and 11th generation processor. Okay, so now first of all we need to check 19 number I have checked, and I'm getting 0 voltage on this. So we will go back and we will find out where is 1.8 volt regulator. As I said you before that earlier generation has S5 state voltages like 3.3 and 5 volt. This was the S5 state voltage we used to get on the motherboard. And from the 6th generation till 9 generation, from 6th generation to 9th generation, you will find that if 3.3 volt is always and 5 volt is also always, then you expect that 1 volt and 1.8 volt you will, of course you will get on the S5 state. In 10th generation, 1 volt is removed, and instead of 1 volt, 1.8 volt, this is VCCIN has taken place. So this is the logic, usual logic we have taught you in our classes in very depth. So if you are interested in our course, then the last number is given, because I cannot get the phone. I cannot make any commitment that I will receive phone. You better to text to Mr. Dildar sir. He will reply you surely. And one more information I would like to give to my old students. They ever have taken our online video course. If they want to update, so you can also update by contacting Mr. Dildar sir. You just have to pay the renewal charge, that is around $78 merely. You can get entire video. Till now we have around 400 videos. Suppose you have taken my course in 2020, you might have got 100 videos on that time. Now the things are increased, like C-type is introduced, BIOS, different problems like TPM error, endpoint security error, and gaming laptops case study. There are the new things we have brought for you. And if you are you have never been a Laptex student, then you can contact to join for the new course. But if you ever been Laptex student, then it is offer for you that you can access our all videos by paying only renewal charge. Okay, so it is not that you have left the renewing your video and now you cannot do, but of course now we have introduced you that you can renew whenever you really don't care about that when you have taken our course, but it is necessary that you should have taken our course, otherwise you cannot get by paying merely renewal charge. You have to first get the new. If you are new, if you ever been the student of Laptex, then you can of course renew your video course. So come back to this story. So this is the regulator PU 1801. Here you have to first of all you need to get 1.8 volt, and I think VS, I think this is S4 state. I think PCH is usually in many motherboard you will find S5 state, or sometime in the S4 state. So let's come on to check. At least you need to trigger. If you are getting like many boards, you will not get it always. Many boards you will have to trigger. You have to turn on your motherboard in order to get PCH power enable signal on for 1.8 volt achievement. Now come and see that do we have this voltage. This is I think here PU 18, because board view is also available. Yes, it is here. Now you just count. I'm checking it, that at least VCC we need to check, that is on the pin number 4. Here is the VCC 3.3 volt. So we have 3.3 volt. Let me set the black on the ground. So here 3.3 volt is available, that is the VCC, and enable is pin number 1. So this power good is generating enable for the VCC IN voltage. So the power good. So forget about the power good. Let's find out that do you have enable for 1.8 itself. So I have turned on. There is no enable at all. So PCH power enable is missing. So maybe PCH power enable is coming from the SIO, and that is why the guy who has worked on it and he knows these things, that this voltage is missing. I hope so. So 1.8 volt you are not getting. So it is coming, since it is coming from SIO, let's find out. I hope so. I have seen in many motherboards. So you just copy this PCH power enable and paste it. It is saying you EC. EC is responsible for this. Okay. Now that is why if it is not coming, so guys thought that by replacing this SIO or by hitting it, maybe I will achieve PCH power enable and it will generate 1.8 volt, and 1.8 volt power good will generate VCC IN. Then you will get VPP enable voltage, and then you will get VDDQ voltage, and rapidly the power sequence will go up to the CPU. Okay. So is it true that the guy he has done the right work? No, because the basic thing, as I told in 3 diagram I have made for you, that the logic of the trigger, the motherboard which is not trigger, there are the 30 points which you have to check. I have taught you in online, offline, and all types of batches which we have received. So 30 logics of not triggering. Like if 19 volt is not present, so the logic behind that, the around 11 signal you need to check, and in IO there are around 10 to 12 signal you need to check to verify that your motherboard will turn on or not. Your RTC entire signals you have to check, DSW signals you have to check, many more uh, error signals you need to check, thermal area you have to verify. So there are the various things you have to check in that uh, point. I'll show you here. Maybe that RTC is checked or not, I am not sure. Only I have shown you the 32 kilohertz is working perfectly. So now let's start from the basic. Then I will show you the IO requirement if there is no problem at all. So hopefully the IO would be good. RTC would be good, I think so. 3.3 volt, good. So what is the logic that it is 3 volt here and 3 volt here, 3 volt here and 3 volt here. What is this? 1.5 volt. So the Ohm's law says you that if there is a 20 kilo ohm resistor is there, the value of I will be decreased, and the voltage value the little bit it will drop, but not as much as you are able to see on the screen that 3 volt on this side, and after 20 kilo it is showing you 1.5 volt. So on maybe it is the SRTC reset. And what is this? Let me show you. So here we have board view, and on the board view I think where is that? CLR, this one. So this one, this is SOC RTC reset. Okay, so this is what I'm checking, SOC RTC reset, and this is the SRTC reset. If you find out this R value, you will find this is the universal RTC section, that 20 kilo resistor is given here as well as 20 kilo is given here. Is there any short circuit or something? You just verify before doing anything. So I am just going to check my capacitor value, which is usually given after resistor. So around 71 kilo ohm we are getting on the capacitor area. Okay, 71 kilo, despite we are going to remove this tiny capacitor. And what is the logic behind it? If this motherboard will turn on after removing this, it means that sus clock PCH is not sending sus clock to SIO, and that is why SIO is not able to trigger, and that is why it is unable to send PCH power enable to 1.8 volt regulator. Got this point? Listen once again what I have said you. If you are just passing your time to see my video, okay, where it has gone I really don't know. Okay, now what I will check here, I will not check anything, I will just clean it here, because it was not short. Okay, so it is called choke. This is the common problem in the DC section, and which is I am going to reveal in front of you. Now we are going to check the same thing, 3 volt on this area and 3 volt must be on this area. This is not 3 volt, still there is no 3 volt. It means we need to check the resistor value. Okay, so come and check. Same value. So the area is chalked, and it is directly going to the PCH. So don't do anything, you just inject around 1.5 to 2 volt on this area. So I have reduced my voltage. There is PCH problem, maybe, but most of the time you will find the tiny capacitor is causing to be 1.5 volt and whatever you were getting. Now I have turned on, and I will increase 1 volt. Okay, and I will move my cursor to milli, 1.1 volt, 1.2, 1.3, 1.4, 1.5, and 1 2 volt. Okay, I think this must be enough. Let's increase to 3 volt. Enough. 2.7 volt I have injected to flush out the choking current. That is why I have injected, otherwise there is no reason, there is no shorting at all. Now I am putting back DC jack into the motherboard. So let me set my power supply to 20 volt, inject the power, and once again check the voltage condition. Here still it is 1.5 volt, that is not good. So I need to increase, let me turn on the same condition I'm getting. So I have to reduce this resistor value. This is quite illogical because I am just doing one thing. When voltage goes low, it means that your current is end up, your current is finished, and then voltage goes to ground or it sink. So don't let it be sink. Let me find a very I think I will use here 1 kilo or 2 kilo ohm. From the scrap motherboard. I need to get Apple motherboard, I think. Come on. Yes. Here I will get 1 kilo. I think that is too much less. 23 ohm. Hundred kilo. Four to 5 kilo is good for me right now. 40 kilo. Come on. 9. 9 I will try first. Okay, 10 kilo. This is the 10 kilo. So remove it. So don't forget to check your RTC section. before going to SIO or anywhere. Okay, I have just half. I have set the half uh, cut value of 20. I have reduced it around 50%. Now I expect that I will get 3 volt on the RTC reset. Now let me set it on the voltage. 2 volt, turn on, the same condition. That is why I was looking for 4K, or because the threshold level of the RTC is 2.6 to 2.7 volt. So remove it. Your PCH is damaged or not after uh, replacing this resistor will be determined. I'm not getting. One kilo would be too much less. I have to stop the current as well. 2 kilo at least. One kilo I am getting too much. 50 ohm. I think nearby sound IC big. I'm looking for a small resistor, not big. 10 kilo. One kilo. Let's check with 1 kilo. I'm not getting 2 kilo. It is taking too much time to find out. The final value of resistor I'm using here, 1 kilo. Vanish. Oh, damn it. Where have you gone? Capacitor. Come again. It is putting here. Verify the value. 1 kilo. Okay, now I expect that I will get 3.3 volt, but what about current? I have injected power, set it on the voltage. Come and check. What do you have? 1.4 volt. What does it mean? It means that PCH is no longer safe. But it is not like that. You just come here and find out that do you have in between something like clicking on this point. You are just coming here, and directly if it is going to across the register or anywhere else. So QK4, what is it? It is something QK4. Here it is QK4. QK4, and let me find out in the diagram. QK4. So it is SOC RTC reset. When EC RTC reset will come to the gate, it will become hash. So this might be leakage, and that is why we need to first of all remove this one. Okay, I don't want to take any risk. I have to increase my EC reset. Removed what they have done here. He has replaced SIO, and I don't know why, and the pin is proper or not, I have not verified yet. Later on we will check it. Now inject the power, and just check it on the RTC. Now it is 3.3 volt. So that area, first of all I have to trace where is my 20 kilo resistor. Remove the one, back to 20. Got this point? After removing that transistor, the voltage increased. The new thing I have seen in this motherboard, the new logic of RTC section. So mind it, this is very common motherboard you might receive. Now come back and place back your old resistor. I don't know what is the value of this, 20 kilo. I don't know the value where I have placed. There are the 3 and 4 resistors I am keeping on this area, and the value is 10k. Where is my 20k? I think this one. Come on. So I have replaced resistor. Yes, this is 20 kilo which I was looking for. Now the voltage must be right on the RTC reset. I have injected power and I must get 3.3 volt on the RTC reset and SRTC reset. Yes, I am getting. Not turn on. Yes, board is turned on and 0.71. It is little bit increased, but one thing is that I don't care about that how much it has taken the current. The matter is that the IO has released enable signal or not on the pin number 1 of 1.8 volt regulator. Let's check. Yes, it has released. Now 1.8 volt is available. Yes, it is available now. Enable for the VCC-IN. Yes, it is available now. VCC-IN 1.8 volt. I think it is here or where? Here. I think not this one. This what was it diagram saying? Because I think this is not 1.8. Yes, this one, the last one. Okay, so this one, check 1.8 volt. So this is the VCC-IN voltage you will receive. So the thing is done. Now I think the rest is on the BIOS, which should not be done, but it is. Here you can see that the guy who has messed the board. So I will reprogram it. Let's check after reprogramming. So I have programmed BIOS. Sorry guys, I forgot to use my headphone. I have just reprogrammed the BIOS. Now placing back. Now let me inject power to the board. I think it must turn on. Where was the light? Backside. So little bit more it has taken. The load. Now I have to further I have to check RAM voltage. VPP is established and VPP really 2.5 volt is generated. Core is missing now. Core is missing. So I think I have to fight for this. So if I get succeeded, mm, I will make the second part of this case study. So guys, this is the second part which I am including in the first part. So I have not paid attention on the CPU that somebody has already baked, and you can see the cut mark uh, while you try to remove the glue from the motherboard. So this happens when you have no knowledge of diagnosing the motherboard. So you do the same job that you have destroyed the motherboard. I have shown you what was the problem in the motherboard. The motherboard IO was not triggering because RTC reset signal was missing, which uh, after replacing, or if you don't, this is the OD section. And what is the OD section? If you ask me, I will not tell you now because I have told you each and everything in my class, uh, video class. So if you remove it, it will work. If you use it, this is the OD section. And if you want to remember, if you want to learn that, in short, in nutshell, I will say you the low will come here and it will be high. When you turn off your motherboard, so this will get low. On that time it comes high. So low, active, enable. So reset, all types of reset need to be high. So this is the OD section. OD area, open drain signal. Uh, it will be switch off. This MOSFET will be switched off, and then you will get a voltage which is coming across the resistor, 20 kilo ohm resistor, and it is reaching here. So because the MOSFET was leak, you remove it, it will work, but maybe after restarting it will turn on again. This types of problem could take place, but as of now, for triggering, for turning it off, it is not required. So but despite I have placed it for my safety purpose. So as I have shown you that the conclusion of this video is here, that the guy who has sent it to me, he has destroyed this motherboard. Through the BGA machine, he has heated up too much to the good CPU, so the good thing become bad and bad thing becomes good. So here, since my processor was absolutely all right, the problem was on the RTC area, and you are baking the CPU, so that is why it is core is unable to be generated here. So the scenario is the very same. I have not done anything, and I am not able to repair this unless I estimate to uh, at least to revolve the processor, if processor is good. So the scenario is the very same, that 102 milliampere load, it is taking all the voltage is generated, but except my core. So what will happen if good processor, if on the good processor you heat up, will it be more good or it is about to die? So it is up to you that how do you diagnose the motherboard. And by showing these types of case study, I want to bring your attention on this conclusion that if you don't know how to diagnose the motherboard, you can get our course, and if you are my student, then you can get a renewal of your video course. So hopefully guys, you have enjoyed this after watching this video, and you have learned something new. Hopefully we will try to make the videos in English, because for a long time I am not making video in English. I was making video but in other languages. So stay tuned, and hopefully inshallah we will see you in the next video. Thank you guys, thank you for watching this video.